The carbon monoxide water gas shift reaction plays a major role in ammonia plant design and operation. Good performance of shift catalyst and attainment of a close approach to equilibrium enhance minimization of carbon monoxide slip from the catalyst system to critical to the efficient economic operation to the plant and ensure maximum hydrogen production from hydrocarbon feedstock. This is a high temperature converter. It contains iron oxide and chromium oxide catalyst. About 75% of carbon monoxide is converted into carbon dioxide. And this is low temperature converter. After cooling at 199 degrees Celsius, carbon monoxide is reduced to approximately 0.3% by volume of dry gas using zinc oxide or copper oxide.
The reaction will be is CO plus H2O will be CO2 plus H2, which means oxygen in H2O will be eliminated. The carbon dioxide is then removed either by absorption in aqueous ethanolamine solution or by absorption in pressure swing absorber, which means we can call it with short name is PSA, using proprietary solid absorption media. In conclusion, the best CO conversion process design will use strengths of highly active catalysts for reactor measuring the conversion of the feedstock for extended period of the time. So thank you. That's all for us.